Okay, so picture this. An AI that doesn't just, spit out an answer it found somewhere online. Imagine an AI that actually thinks through a problem, one that reasons step by step, like a mathematician, checking its own work and learning from its mistakes as it goes. It honestly sounds like pure sci-fi, right? Well, Microsoft may have just made it a reality. Let's get into it.
So, what does that even mean, an AI that syncs? For the last few years, the whole story in AI has been about these gigantic models. We train them on basically the entire internet, and they get incredibly good at predicting the next word in a sentence. And don't get me wrong, that's amazing. But is recognizing patterns the same thing as reasoning? This new approach, well, it challenges that whole idea. And this slide right here gets to the absolute heart of it. On one side, you've got the giants, these massive models that are kind of like a superpowered calculator. They just predict the answer based on tons and tons of data. But on the other side, you have rStar2. It's more like a clever detective. It's a way smaller model, but it doesn't just guess, it acts. It tests its own theories, and then it refines its conclusion. It is a completely different ballgame. So let's really dig into what makes this thing a new kind of thinker. Because this isn't just a simple software update. We're talking about a totally different way to build an intelligence. The most important word to understand here is agent. Unlike a traditional AI that just gives you a static answer, an AI agent is dynamic. It has tools it can use. For Star2, its main tool is a Python coding environment. So it doesn't just think about a math problem, it can actually write a little piece of code to help solve it, run the code, and then look at the result to see if it makes sense. It has agency. And here is the absolute kicker. This whole agent is built on a pretty small 14 billion parameter model. Now, just to give you some perspective, other top models are in the hundreds of billions. Some even claim trillions of parameters. And yet rStar2 is right up there competing with them, and sometimes even beating them. It's the classic story of brains over brute force. Okay, so what is the secret sauce? How can something so much smaller be so incredibly powerful? Well, the magic isn't in the size, it's all in the process. Instead of just making a one-and-done prediction, rStar2 works in this constant loop. First, it gets a question. Then, it writes a little bit of code to try and solve one piece of it. And this next part is critical. It actually executes that code. Right away, it gets feedback. Did the code work? Did it throw an error? Does the output even look right? And based on that real-world feedback, it refines its next step. It's literally thinking step by step. Now, all of this is possible because of three core ideas. The first one is agentic reinforcement learning, which, is a mouthful, but it's really just a fancy way of saying it learns by doing. The second is something called the GRPO-RoC algorithm, which is like a really smart teacher that rewards the AI for taking the right reasoning steps, not just for getting the final answer. And finally, there's the Python execution environment. That's its sandbox, its lab, where it gets to run all its little experiments. And this quote just sums it up perfectly. A human mathematician doesn't just magically write down the final answer to some complex proof. No, they work through it, line by line, checking their logic as they go. That is exactly what rStar2 is doing, just with code. It's showing its work. Of course, this all sounds amazing in theory, but what happens when you actually put it up against some of the hardest problems out there? Before we even get to the results, you have to see this. The entire training process for this agent behavior took just 1 week, on a pretty small cluster of only 64 GPUs. In the world of large-scale AI, that is a shockingly small amount of time and resources. And here are the results. This chart shows how it did on the AMU, which is a notoriously difficult math competition for high schoolers. And you can see rStar2, this little 14 billion parameter model, just holding its own, and in some cases, blowing past models that are hundreds of times its size. It's not just playing in the same league, it's a top contender. On one version of that exam, it hit a staggering 80.6% pass rate. That's not just good, that's genius-level performance. And it got there through methodical reasoning, not just by matching patterns. And this wasn't just a one-hit wonder. It scored almost 70% on another version of the test, and, maybe even more importantly, its skills transferred. Even though it was trained mostly on math, it did exceptionally well on scientific reasoning problems. That shows this way of thinking is actually adaptable. So, a smart AI that's great at math, that's cool for sure. But why does this really matter for the future of AI and, for us? Well, there are three huge takeaways here. First, smaller is better. A lot better. It means we could get this kind of high level performance without spending astronomical amounts of money and energy. Second, this is just better reasoning. That real time feedback loop stops the AI from making a tiny mistake early on that snowballs into a completely wrong answer. And third, it's future ready. This could be the path toward an AI that can truly learn a skill, like reasoning, and then apply it to totally new problems it's never seen before.
Now, we have to be balanced here. It's not perfect. Star2 is built for math and coding problems. It's not a general chatbot. Also, that whole process of constantly running code can actually be pretty resource intensive in its own way. And like any AI, its performance is still fundamentally tied to the quality of the data it was trained on. But even with those limitations, what rStar2 represents is a major leap forward. It's a real shift from an AI that predicts to an AI that problem solves. And it forces us to ask a really profound question. For years, we've been building AI to match our intelligence. But what happens when we build AI that can truly reason, and one day might just do it better than us?